Hey guys, it's Monday, March 23rd, the beginning of the second week of the Corona shutdown from school. I'm going to bring you more welding knowledge from the Wolf Den. Pretty good, huh? I hope everybody's doing well. I know now that we're on a mandatory stay at home or whatever it is, you're going to be getting a little bit stir crazy. I encourage you to stay home. Let's prevent the spread of this virus as much as possible and try to get back to normalcy as soon as possible. That being said, today we are going to talk about welding joints, positions, and symbols. But today we're going to talk about the parts of a weld. We're going to hit this objective right here. Identify and define the parts of a fillet weld and a groove weld. Of course, this is now uploaded or added to your classes for Tooling U, so make sure you log in there and go over this material in Tooling U as well. Here's one quick thing. I'm not going to have you do the assessments at the end of each chapter. The only assessments that you're going to be taking are the quizzes associated with the lessons that I put out. Does that make sense? So only the quizzes that are done over Google Forms are going to be graded and put into your grade books, not the assessments at the end of the Tooling U. So really, all you have to do is pay attention here, use the content that you have, or your textbook that you have online to kind of follow along with the video, and then complete the quiz that I send out in Google Forms, and you're done. It's that simple. But here's another quick note. This isn't optional. This is mandatory. This is the only way we stay moving forward with our class and our program for the rest of this year, provided that school's out the rest of the year. I don't know that. I'm just saying, if that's the way this is going to be through the rest of this year, these are the only grades that you're going to have. So please don't think that this is optional. It is mandatory. I need you to complete this, okay? Let me know if you have any problems doing that. So today, we'll start with this introduction right here. Doctors, here we go with these awesome introductions, as we always like to poke fun at. Doctors must study the human anatomy before they can treat patients. Not only must they be familiar with each body part and how it functions on its own, they must also know that part's role in working with the entire body. Welders, in turn, must be able to identify all the components of a weld, how each part operates, and how it works within the whole structure. There you go. You're almost doctors. In addition, a professional welder knows a variety of positions to use when working with different parts of a weld. Mastering these is an essential part of a welder's job, just as knowledge of the human anatomy is a vital part of being a doctor. So you can see how you guys are very similar to doctors, right? Okay. The parts of a weld. This is important. There are two types of welds. Two. One, fillet weld, and the other one, a groove weld. Groove welds, let's see if I can get control of this thing. Groove welds are most often used to form a butt joint. So again, that groove weld forms a butt joint. Two pieces of material come together to form a butt joint. Those are typically groove welds. In fact, they're always groove welds. They're most often to form a butt joint and a joint between two pieces of metals that are aligned edge to edge with another. Fillet welds are when two pieces of material are joined together to form one or more right angle. A fillet weld can be a lap joint, T-joint, or corner weld. The parts of a single pass fillet weld: there's the face, which is the top of the weld, a toe, which is the edge of the weld. We've gone over that several times, the toes of the weld. The root, it's the depth of the penetration. Reinforcement, weld metal in excess of the quantity required to fill a joint. So anything above flush, right, in that joint. Or we'll go over a T-joint. The two axes are 2 points in the straight line. Anything beyond that straight line from toe to toe is reinforcement. Okay, but we are all familiar with reinforcement being anything above flush in a groove weld scenario. So say you're welding a flat plate with a groove weld, Anything which would be the cap, a cap weld, is reinforcement. Okay. Legs, we know that the leg is the length of the weld sides from the root to the toe. So anything from the root of the weld out to the toe on a T-joint, that would be up to the toe, and from the root over to the toe. Okay, so there's two legs on a T-joint. The actual throat, the shortest distance between the weld root and the face of the weld. The effective throat is the distance between the weld root and the line extending from toe to toe of the weld. Theoretical throat, the distance from the beginning of the joint root perpendicular to the hypotenuse of the largest right angle that can be inscribed within the cross-section of a fillet weld. This dimension is based on the assumption that the root opening is equal to 0. That's a whole lot of stuff to try to remember. I'm going to show you the picture of that. It'll be a lot more simple after I bring that picture up. The heat affected zone, otherwise known as HAZ, the portion of the base metal that has not been melted, but within which the mechanical properties have been altered by the heat of the welding. So it's not the part of the weld that's been directly melted or the filler itself. It's the area around that weld that has been mechanically altered due to the heat of the weld. So that area that's been heated up and then cooled, those mechanical properties have been altered in that heat affected zone because of that welding. So we're going to take a quick look at these diagrams here. Here we're looking at a T-joint, and we can see the actual throat is the distance from the root to the outside of the face, or the outermost portion of the reinforcement. The effective throat is from the root, and if you draw a line straight across from the toes of the weld, this toe here to that toe, from that line to the root would be the effective throat. We got the toes of the welds on either side. Everybody watching this video should know what a toe of the weld is. And we have the weld face. Okay, that's the outermost portion of that weld. That's the face of the weld. We know what leg lengths are. So we got the legs shown here and vertically on this T-joint. You can see that on both sides, legs. And then we got the joint root, the weld root, which is the weld material coming in to the root itself or penetrating the root. And then you see the heat affected zone. The heat affected zone is this shadowed area around that weld joint. The heat affected zone can be larger or smaller depending on the heat input. Okay, so the more amperage you put into this, the more the heat affected zone, or the wider the heat affected zone is going to be. It should be proportional with the weld parameters of the whatever type of filler metal you're using. You have the theoretical throat, which is again from the joint root, not the weld root, but from the joint root to the I guess imaginary line from toe to toe. So it's from the joint root, not the weld root. There's a difference. That weld root is that penetration into the root itself, okay? That penetration, that weld root extends past the joint root. The joint root is basically what you can see, that 90-degree angle, that perpendicular joint that comes together. You can see that, physically see that in the T-joint before you weld it. In order to see the weld root, you would have to cross-section that T-joint to see the weld root portion, okay? And then reinforcement. I think we've gone over that. If not, we're going to hit on that. Reinforcement is anything above that line between the two toes. So wherever that imaginary cross-sectional line is between the two toes of the weld, anything above and beyond that is weld reinforcement. Okay, that's very important. Now this is what a T-joint looks like in all those different components. I almost scrolled up like the smartboard at school. I got to use this fancy mouse. And B is showing what all these different components look like on a groove weld. Okay, this is a cross-section of a groove weld. You see the reinforcement? Again here, reinforcement is anything above the top of that theoretical throat. So from the toe to the toe, straight across, Anything above that, which would be a cap, right? You know, a fill or a cap pass on like your D11 structural cert. So anything above those two toes, that imaginary line between the two toes, anything above that is reinforcement. You can see the face of the weld. Obviously, we just went over the toes. That's the outer edges of that weld. The theoretical throat, again, is not from the weld root. It's from the root of the joint itself. So from the root of the joint to that imaginary line from toe to toe, the depth of that joint, that's actually the theoretical throat. Okay? The weld root reinforcement, you can see that. You can see that shadowed portion of the weld that's gone through or penetrated that weld joint. That is the weld root reinforcement. The root opening, I'm hoping you guys know what that is by now. The root opening is that distance between the two beveled plates, and you know, that creates the root opening. The heat affected zone, you can see that around the outer edges of this weld joint. Again, very similar to a T-joint. That heat affected zone is just the heat or the zone outside of the weld itself that's been affected by the heat of the weld, and it affects the mechanical properties of the material. Let's see. So Wednesday, my next video will be coming out. We're going to go over types of weld joints. We're going to identify butt joints, corner joints, edge joints, lap joints, and T-joints. I know you guys know these, but the point is, as we keep moving forward with this, we're going to kind of go over, you know, kind of redo some of the stuff that we've already done this year, just to keep it fresh in your mind. It's going to be more of the basic stuff applied to our program. I know things are busy at home. I know you have work for other classes. I hope these videos and these quizzes are working well for you. If so, I want to hear that feedback from you. If not, I want to hear that feedback too. Also, if it's not working well for you, provide me some, you know, some stuff that kind of helps me guide me in a way that's going to work best for you, that you're going to learn best from. I'm not perfect at this, especially not this online stuff. Never done this before. So feedback from you guys is going to be very, very important as we move forward. That's all I have for today. To kind of recap, we went over the parts of the welds. We were able to identify the various parts of a T-joint and of a groove joint. We know that there are two types of welds, a fillet and a groove. That's very important for your quiz following up. Make sure you pay attention to that. And that's all I've got for this Monday. I hope you guys are staying safe. I hope you guys are staying well fed. And hopefully soon enough we'll put a large damper on the spread of this virus, and you'll be able to get back to life as normal. I miss you guys. If you need anything, reach out. You know how to get a hold of me. Thanks for tuning in, and I'll see you Wednesday.